Okay, in this video, we're going to be doing Calc AB problem set number 15, link to the problems and a playlist of all the problem sets in the description below. Let's take a look. State the three-part definition of continuity at a point. Okay, continuity at a point. So you need the limit as x approaches c of f of x exists. You need f of c exists. And then finally, you need the limit as x approaches c of f of x equal f of c. So it's a three-part thing. I want you to run through all three parts every time. Just do it. Put that on your note card or whatever. Just constantly review that. Limit definition of continuity at a point. So limit exists, function exists, limit equals value of the function. I count them off on my finger, my fingers every time. All right, we're going to do a couple problems related to that now. Find the value of k so that the function below is continuous. All right, so if this thing's going to be continuous, we need the limit to exist. So we're going to need to find the limit. So I'm going to find the limit as x approaches 6 of f of x. Limit as x approaches 6 of f of x. So remember, we use we don't care what it is when it is 6. We want, when it's not 6, we want it to approach something. So we're going to find the limit as x approaches 6 of x squared minus 36 over x minus 6. This is one of the first types that you learn. I'm going to factor, and then I'm going to cancel, and then I'm just going to plug 6 in, and I get 12, right? So that's what I've done there. Now I need to I need this to be continuous, right? So I need the limit to equal the value of the function. So I need f of 6 to be equal to 12. And if f of 6 is equal to 12, that means that 2k plus 5, which is f of 6, must equal 12, which means that k must be 7 over 2. So it's kind of a lot. I don't know if it's a lot of work. It's the same work every time. So once you've done a couple of them, it doesn't really feel that bad. But now what I want to do is make sure I've answered the question. So what I'm going to do is I'm going to say, if k is equal to 7 halves, the limit as x approaches 6 of f of x equals f of 6 equals 12. Therefore, f of x is continuous. So I've justified it. The question didn't really ask me to justify it, but sometimes it does. So I wanted to practice that. And this one wasn't that bad, so I didn't feel bad, putting in the work there. All right, find a and b so that the function below is continuous. This one will be twice as annoying to justify, and it doesn't say to justify, so I'm not going to. I'm just going to do nice work, get my answer, and move on. All right, so first I'm going to need this thing to be continuous at x equals 1. So I'm going to need the limit from the left to equal the limit from the right as x approaches 1. So I need this to be true. The limit from the left to equal the limit from the right. Well, if that's the case, I look at the definitions. I say limit as x approaches 1 from the left of f of x is the limit as x approaches 1 from the left of ax plus b, because that's where you are when you're to the left of 1. And then when you're to the right of 1, you're on the branch 5x plus 4. So that's where that work has come from. Now I'm just going to sub 1 into both of those, and I'm going to get a plus b is equal to 9. That's an equation that has two unknowns, so I'm going to need a second equation. The place I get the second equation is the fact that I also need to force this thing to be continuous at 3. So it's the same work. The limit from the left has to equal the limit from the right at 3. I look at the definitions and I sub those in. So that means the limit as x approaches 3 from the left of f. Sometimes I confuse f's and 5's. Limit as x approaches 3 from the left of 5x plus 4 equals the limit as x approaches 3 from the right of 2x squared plus ax plus b. We're going to plug 3 into both of those because they're both continuous on their own. So if we plug 3 in, we get the value of the limit. So that's going to give me 19 equals 18 plus 3a plus b, or 3a plus b is equal to 1. All right, so I have two equations, two unknowns. That's a system. So 3a plus b is 1, a plus b is 9. I'm going to subtract down. So I'm subtracting the second equation from the first, and that's going to give me 2a is equal to negative 8, or a is negative 4. If a is negative 4, just use a plus b is equal to 9. That means that b would have to be 13. We don't need to justify here, so I'm not going to, because that would be a lot of writing. All right, let's take a look at one more. Given that r of x is 3 cosine pi x over 2 plus 5e to the x minus 4, determine if the function below is continuous. So this is I tried to do 3 different types of problems, I guess, more than one branch with a system, only one branch, and then this weird thing where they give you an extra function, which is not uncommon. So I'm trying to do different types. All right, so we need to find the limit as x approaches 4 from the left of f of x and the limit as x approaches 4 from the right of f of x and see if they're the same. If they are, we'll compare them to the value of f of 4, which will obviously be equal to the limit from the left because the left is less than or equal to 4. But here goes. So I want the limit as x approaches 4 from the left of f of x. Well, when you're to the left of 4, you're using r of x, so it's really the limit as x approaches 4 from the left of r of x. R of x is defined, so it's the limit as x approaches 4 from the left of 3 cosine of pi over 2x plus 5 e to the x minus 4. Okay, so what I'm going to do is I'm going to plug in 4. The cosine of 2 pi is 1, so I just end up with 3 plus 5 e to the 0, e to the 0 is 1, so we get 3 plus 5, which is 8. Then we're going to find the limit from the right. So the limit as x approaches 4 from the right. We look at the definition, we're like, oh, to the right of 4, we use the quantity x minus 5 cubed plus 7. So limit as x approaches 4 from the right of the quantity, blah, blah, blah. Plug in 4, and you get 4 minus 5 is negative 1. Negative 1 cubed is negative 1. Negative 1 plus 7 is 6. So I have that. And then the limit from the left did not equal the limit from the right, which means the limit does not exist. And if the limit doesn't exist, the function can't be continuous. So I'm going to write that down. Since the limit as x approaches 4 of f of x does not exist, f of x is not continuous, and I think that problem is done. All right, this problem set is also done. I hope you found this helpful, and good luck.